So hi guys, so today we would be looking at this question, that is validate binary search tree. So basically what we have to do is in the question is given the root of a binary search tree and we have to determine if it is a valid binary search tree. So what is a valid binary search tree? Basically the right element of the binary search tree is always greater than the root element on which we were initially, and the left element would always be less than it. Here you can see 2 is the initial and 3 is greater and 1 is less. Similarly here you can see 5, and then here you can see it's 4. So you can see it's not at all possible because at right the value should be greater. And similarly this is how we would be looking. So if you want, you can use the recursive approach, that is creating a boolean function and checking if it's possible for it for the tree to again and again go on recursion till right and left. But I would be telling you the iterative approach, that is using stack. So basically what we would be doing is we would be declaring a stack, as you can see here, and we would be putting the element one by one. Suppose I have put here 2. Now I would be putting 2, and now I would be popping it out. Before doing that, I would consider this as previous element and storing its value here in this element, and then I would be going to write, and we would be seeing at that moment that at right, when we go to write, was this element less than this element? Because if that is so, suppose 3 was greater than 3 is greater than 2 here, it is not a problem. But suppose it was 1 here, and 1 is not great, definitely is not greater than 2, then at that point we would be returning false. So if it's not clear through the structure, I would be simply coding it out here. We would be declaring a stack here, and let's name it stack only, and let's do it new stack and tree node, because we would be storing those value here only. So we have declared it, and let's declare a previous element. Let be prev, and we would name it null. So after that, while stack is empty, and stack is empty, and we would be seeing is not empty, I mean, so is not empty, and root is also not equals to null, because if root is null, how can we keep doing it again? So now we would be inserting the elements. So while root is not equals to null, we would again be checking that, uh, and if stack, and if this, we would be adding it to the stack, that is stack dot add root. And now we would be going to left, that is root is equals to root dot left. Okay, yeah. Now we would be seeing, we would be putting root as the value by looking into the stack, that is the top element that we have just added here, and we would be simply emptying the stack, empty the stack. Yeah. Now if the previous value is not null, and the root dot value, that is the value which we are considering now, is less than the previous value, because we are going to left, and we are, for the first step this won't work definitely. How is it even possible? Because at first we declared it as null, but from the second step, when we would keep adding it, that is we would go to right and left, then it would start working, and we would do return false. Now you would be asking that where are we declaring the previous value? So here it is, previous equals to the root, and we would be going to write now, that is root dot write. And if this condition, the most important one, if this condition work, then we would be returning for false, else we would be returning true. Yeah. Now I would be running the code here, as it has passed this basic test case. And now, yeah, it has passed. I know it's taking a bit long time, but yeah, it depends every time you submit it. If I submit it again, maybe it takes different, because it was 38.6 MB last time and it's 39 MB this time. It keeps increasing and keep decreasing every time you submit it. And if you still feel like that it is not the correct approach, you can even use the recursive approach. It's quite easy if you just use the validate binaries, validate boolean function, it would do the work. But yeah, from the interview point, I would I just want you all to make sure to use this approach, because it uses stack data structure, and it shows your implementation knowledge, not only recursive knowledge, and how iterative approach can even work using a data structure. So this was it for the video. So thank you and have a nice day.